Hi everyone. This time we'll talk about elevation models. So Fluidit software supports DEMs, which stands for Digital Elevation Models. They are used for many purposes, like fetching component elevations, visualizing ground elevation, and so on. Especially important they are in stormwater models and flood simulations, but on a basic level they are used in almost all models. You can find the DEM manager in the model tree. Adding new elevation models is done via a right mouse click. Although usually just one layer is enough, user can have several elevation models set up. There are two uses for this. First of all, you can have different elevation models for different things. Aside common ground elevation, it is possible to set up other elevations, such as invert elevation or groundwater level. Secondly, even with the same elevation type, such as ground elevation, user can have several sources set up. If so, the software first tries the topmost layer. And if no elevation is found for that place in that layer, then the next layer is looked, and so on. This feature is most typically used when user has more accurate data from a small area, and then another, less accurate source can be used for places outside that area. Let's then have a look at the actual layers and their properties. Basic elevation model is for integrated elevation sources. These sources and their accuracy around the world varies. They are fetched via internet from the corresponding servers, so access to these internet addresses is required for the elevation data to be downloaded. See our installation guide for more details. This is the most common basic use of DEMs and covers most needs. Just use one integrated source as your ground elevation, and that is it. Add grid DEMs and sparse DEMs can be used to add elevation from individual files. Grid is used for raster format data, that is TIFF files, and sparse is used for vector or tabular format data. For example, GeoJSONs as a vector or CSVs as tabular. Add WMTS DEMs can be used to add web map tile service data from a server. This is set up the same way as map servers in background layers. Please see that tutorial video or our wiki pages for more information how to add these. Finally, virtual elevation models can be used to calculate new elevation models from another already existing elevation models. One could, for example, make an elevation model which is always 2 meters below the ground level. Now we have learned how to add and modify elevation layers. There is one more feature to cover, and that is Dem Modification Areas. These are area components that can be used to modify your elevation model in a specific area. You can add these manually from the Components bar or use import functionalities. First, select what type of elevation you wish to modify, and then select whether you wish to enter absolute values for that elevation, or do you want them to be relative to existing values, that is, for example, add or subtract from the current elevation. Elevation field is where you input the value itself. Now this interpretation depends on the previous selection, absolute or relative. With these settings, I would have an absolute elevation of plus 20 meters above sea level in my whole modification area. If I change my settings to be like this, now I am lowering the current ground elevation by 5 meters in this area. Finally, slope parameter can be used to adjust the slope of the change at the border of the DEM modification area. Use 0 if you want no slope at all, so that is a rapid vertical change, like a building. Now we have learned how to add and manage elevation models. Try different sources and find what is suitable for your needs.